Hello students. So in this video I am going to explain some of the multiple choice questions from the first chapter, some basic concepts of chemistry. So from this video you will get an idea to solve some of the questions arising in competitive exams. First question. If the density of a solution is 3.12 gram per milliliter, the mass of 1.5 milliliter solution in significant figure is. Options are first one 4.7 gram, second one 4680 into 10 raised to minus 3 gram, third one 4.680 gram, fourth one 46.80 gram. So let us see the solution. So we know that formula for density D is equal to m by V, that is mass by volume. Here we require mass, density is given and volume also given. So you have to find out mass. So mass is equal to becomes density into volume. Substitute the values. So here D is equal to 3.12 gram per milliliter and volume is equal to 1.5 milliliter. Hence mass is equal to 3.12 gram per ml into 1.5 milliliter. You will get an answer of 4.68 gram. But this answer you have to write it in significant figures. So here in these two numbers 3.12 has 3 significant figures and 1.5 has only 2 significant figures. So result should not consist more than two significant figures. Hence we have to convert this to a number of 2 significant figures. So we have to round off the number. So here after 6 it is 8 more than 5. So plus 1 you have to add to the number 6 here. So it becomes 4.7 gram. So 2 significant figures must be there in the result because here it is having 2 significant figures. Hence the correct answer is option 1. Question number 2. What will be the molarity of the solution containing 18.25 gram of HCl gas in 500 gram of water? So options are given. First one is 0.1 molar, second one is 1 molar, third one is 0.5 molar, fourth one is 1 molar. Solution. So you know that molarity is equal to number of moles of the solute divided by volume of the solution in liter. So here you have to calculate two things, number of moles and volume of the solution in liter. So number of moles of the solute can be calculated by using the formula mass divided by molar mass. So mass of the solute, that is HCl gas, is 18.25 divided by molar mass of HCl you have to calculate here. So molar mass can be calculated by adding atomic masses of atoms present in a molecule. So here H is having atomic weight of 1 and chlorine is 35.5. So 1 plus 35.5 it becomes 36.5. And mass by molar mass will give number of moles, that is 0.5. Next you have to calculate mass of the solution. So it is equal to combination of solute and solvent. So solute is 18.25 gram here, that is HCl gas, plus water is 500 gram. So it will give rise to total mass of the solution, that is 518.25. Next you have to convert this mass. So it is in gram, you have to convert it to liter. So for that the standard you have to use here. So 1 gram is equal to 0.001 liter. By using this you can convert this number to the liter. So that is volume of the solution in liter is equal to 518.25 into 0.001 and it gives answer in liter. Next, directly substitute in the formula of molarity. M is equal to 0.5 mole, that is number of mole, divided by 0.51825 liter, that is volume of the solution in liter. So if you simplify this one, you will get answer of 1 molar. Hence, the correct option is option 4, 1 molar. Question number 3. What will be the molarity of the solution which contains 5.85 gram of NaCl per 500 ml? So options are, first one is 4 mole per liter, second one is 20 mole per liter, third one is 0.2 mole per liter, fourth one is 2 mole per liter. Solution. You know that molarity is equal to number of moles divided by volume of the solution in liter. So number of moles can be calculated by using that formula, mass divided by molar mass. So number of moles is equal to 5.85 divided by 58.44, that is equal to 0.1001. Where mass of the NaCl is 5.84 and molar mass you have to calculate by using the atomic masses of sodium and chlorine. So atomic mass of sodium is 23 and chlorine is 35.5. If you add both, you will get molar mass of sodium chloride, that is 58.44. Okay, so number of moles you got. Next, directly substitute number of moles in the molarity equation and volume of the solution in liter you have to write. So 500 milliliter, when you convert it to liter, it becomes 0.5. So answer is 0.2 mole per liter. Hence, correct option is third one, 0.2 mole per liter. Fourth question, 4.2 gram of NaHCO3 on reaction with the 10 gram of acetic acid liberated 2.2 gram of carbon dioxide gas. Find the mass of the residue left. Options are A 10 gram, B 12 gram, C 11 gram and D 13 gram. Solution. According to the law of conservation of mass, mass of reactant is equal to mass of product. So law of conservation of mass states that matter can neither be created nor be destroyed, but they can be converted from one form to another form. Hence, during a chemical reaction, mass of reactants must be equal to mass of products. Hence, here in this reaction, reactants are sodium bicarbonate and acetic acid. So, their masses are 4.2 plus 10 gram. Then, product is, one thing is carbon dioxide and remaining mass will be the mass of the residue. So, directly you can find out the value of X, that is 4.2 plus 10 minus 2.2, that equal to 12 gram. So, answer is option B, 12 gram. Question number 5. Which of the following statements about a compound is incorrect? First statement. A molecule of a compound has atoms of different elements. Second statement. A compound cannot be separated into its constituent elements by physical methods of separation. Third statement. A compound retains the physical properties of its constituent elements. Fourth statement. the ratio of atoms of different elements in a compound is fixed. So from all these four, you have to choose the one which is incorrect. So let us see one by one. First statement says that a molecule of a compound has atoms of different elements. So this statement is correct one. So obviously molecule will consist of atoms of same element or different element. So second statement, if you consider, compound cannot be separated into its constant elements by physical methods of separation. So second statement also correct one, because to separate the compound into its constant element you have to follow some of the chemical methods. Hence second statement is correct one. We cannot separate it by using physical methods. Third statement, you can see that a compound retains the physical properties of its constituent elements. So this is not correct statement. So if you consider a compound and if you consider the constituent elements present in that compound, those elements in the room temperature, they may have different physical states, and the compound may contain different physical state. For example, if you consider the formation of water, H2O, in room temperature H2O will be in liquid state. If we consider the constant elements present in the water, that is hydrogen and oxygen, these two elements will be in gaseous state at room temperature. Hence uh, physical properties or physical state is not same as that of the constant elements for a compound. Hence third statement is not correct. It is incorrect. Take the fourth statement. The ratio of atoms of different elements in a compound is fixed. So obviously during formation of compound, there will be fixed ratio of atoms which are combining. Okay. So here only third option is incorrect. So answer is third one. Question number 6. A measured temperature on Fahrenheit scale is 200 degree Fahrenheit. What will this reading be on the Celsius scale? Options are given. First one is 40 degrees Celsius. Second one is 94 degrees Celsius. Third one is 93.3 degrees Celsius. Fourth one is 30 degrees Celsius. So solution is, so you are having a formula, so that is degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. Substitute the values here. Fahrenheit is 200 degree Fahrenheit here is equal to 9 by 5 degrees Celsius plus 32. Next you simplify this one. So 200 minus 32 becomes equal to 9 by 5 degrees Celsius. It becomes 168 is equal to 9 by 5 degrees Celsius. So 168 into 5 by 9 equal to 93.3 degree Celsius. Therefore, correct answer is option 3. Seventh question. 8 gram of NaOH dissolved in water to form 500 ml of its aqueous solution. If density of the solution is 1.2 gram per milliliter, then find the molarity of the solution. So options are, first one is 1 molar, second one is 0.25 molar, third one is 2.04 molar, fourth one is 0.34 molar. Let us see the solution. So weight of the solute is given, that is 8 gram. Volume of the solution is also given, 500 ml. And density is also given, that is 1.2 gram per milliliter. You can calculate weight of the solution by multiplying volume and density, because density is equal to mass by volume. Mass is equal to density into volume. Hence 600 gram is the weight of the solution. Then weight of the solvent can be calculated by subtracting weight of the solute from weight of the solution. That is 600 minus 8 equal to 592 gram. Then you can Calculate molarity by using the formula weight of the solute divided by molar mass of the solute into 1000 divided by weight of the solvent. Substitute all the values. So weight of the solute is 8, molar mass of the solute is 40, that is molar mass of sodium hydroxide. It can be calculated by adding atomic masses of sodium, oxygen as well as hydrogen. Then into 1000 divided by weight of the solvent, that is 592. So it will give rise to an answer of 0.34 molar. Therefore, correct option is option 4, 0.34 molar. Question number 8. Which of the following reactions is not correct according to the law of conservation of mass? First one, 2mg plus O2 gives rise to 2mgO. Second one, C3H8 plus O2 gives rise to CO2 plus H2O. Third one, P4 plus 5O2 gives rise to P4O10. Fourth one, CH4 plus 2O2 gives rise to CO2 plus 2H2O. So, law of conservation of mass states that matter can neither be created nor be destroyed. So, hence during a chemical reaction, number of reactants molecule near reactant equal to number of product, or masses of the reactant must be equal to mass of the product. So, to say chemical equation must be balanced. So, first equation if you observe, it is balanced reaction, hence this obeys law of conservation of mass. Second reaction if you observe, so here carbon is 3, here carbon is 1, hydrogen is 8, here hydrogen is 2. So, second equation is not balanced, hence it is not correct according to law of conservation of mass. Third equation if you observe, so in the reactant side phosphorus is 4, in the product side phosphorus is also 4. Number of oxygen in the reactant side is 5 into 2 equal to 10, in the product also 10. Hence option 3 is balanced. It is correct according to law of conservation of mass. Option 4, number of carbon is 1, in the product side also 1, hydrogen in the reactant side is 4, product side also 2 into 2 4, oxygen in the reactant side 2 into 2 4, product side also 4, 2 plus here 2, also 4. Hence fourth equation also balanced. It is correct according to law of conservation of mass. The one which is not correct is second one. Hence option is, answer is second option. Question number 9. The mass of a molecule of water is option A 3 into 10 to the power minus 25 kg, option B 3 into 10 to the power minus 26 kg, option C 1.5 into 10 to the power minus 26 kg, option D 2.5 into 10 to the power minus 26 kg. Let us see the solution. Mass of molecule of water is equal to molar mass of water divided by Avogadro number. So this is got by the formula. So number of moles of substance is equal to mass divided by molar mass. So here mass of the molecule is required. So mass of the molecule is equal to molar mass divided by number of moles of the substance. So number of moles of substance, 1 mole of substance, number of moles is equal to 6.023 into 10 to the power 23, that is Avogadro number. So simplify, you will get an answer of 3 into 10 to the power minus 26 kg. So hence option is B. Question number 10. Which of the following terms are unit place? Option A, molality. Option B, molarity. Option C, mole fraction. Option D, mass percent. So you know that molality is having a unit of mole per kg. Molarity is having a unit of mole per liter or molar. So mole fraction is not having any unit and mass percent is also not having any unit. Hence, the correct option is C and D. Answer is C and D. So these two quantities are not having unit. They are unitless. Question number 11. 16 gram of oxygen has same number of molecules as in A. 16 gram of carbon monoxide, B. 28 gram of nitrogen, C. 14 gram of nitrogen and D. 1 gram of H2. So 16 gram of oxygen is equal to 1 atomic mass unit. So here 16 gram of carbon monoxide is not equal to 1 atomic mass unit. So 28, option B also not equal to 1 atomic mass unit. If you consider option C and D, 14 gram of N2 is corresponding to 1 atomic mass unit. And option D, 1 gram of H2 is also equal to 1 atomic mass unit. So here option C and D are 1 atomic mass unit and 16 gram of oxygen is 1 atomic mass unit. So 1 atomic mass unit substances will consist of same number of molecules. Hence options are C and D. Question number 12. The number of significant figures in the number 1.065. Options are A3, B4, C2, D1. So here if you consider this number, this first digit that is 1 is a non-zero, hence it is significant, and this 0 it is present in between two non-zero digits, hence this is also significant. 6 and 5 both are significant because they are non-zero digits. So hence number of significant figure is 1, 2, 3, 4. The option is option B, 4. Question number 13. Number of moles of NaOH present in 2 liter of 0.5 molar NaOH is option A 1.5, option B 2.0, option C 1.0, option D 2.5. Let us see the solution. So given values are volume is equal to 2 molar, molarity 0.5 molar and number of moles we have to calculate. For the calculation of number of moles, here we can use the formula of molarity. So molarity is equal to number of moles of solute divided by volume of solution in a liter. Substitute the values. So molarity is 0.5 equals moles divided by 2. So moles becomes equal to 0.5 into 2 equal to 1. Hence correct answer is option C. Question number 14. The empirical formula of a compound is CH2. 1 mole of this compound has a mass of 42 grams. Its molecular formula is option A C3H6, option B C3H8, option C CH2 and option D C2H2. Let us solve this one. So empirical formula of a compound is given, that is CH2. You can calculate empirical mass of the compound by adding atomic mass of carbon and hydrogen, that is 12 plus 2 equal to 14. Molecular mass of the compound is given, that is 42. So we can calculate coefficient N by dividing molecular mass with the empirical mass. So 42 divided by 14 equals 3. So N into empirical formula gives the molecular formula. So 3 into CH2. Hence molecular formula is C3H6. Therefore correct answer is option A. Question number 15. What is molarity of 0.2 normal sodium carbonate solution? Option A, 0.1 molar. Option B, 0 molar. Option C, 0.4 molar. Option D, 0.2 molar. Solution. So we have a formula for molarity, that is molarity is equal to normality into equivalent mass divided by molecular mass. So here normality is given, that is 0.2 into equivalent mass we have to calculate, and molecular mass will be 2 into equivalent mass, because here 2 cations are present. So if you simplify this one, m get cancelled, 0.2 divided by 2, it is equal to 0.1 molar. Hence correct answer is option A, 0.1 molar. Question number 16. Which of the following pairs have the same number of atoms? Option A, 16 gram of O2 and 4 gram of H2. Option B, 16 gram of O2 and 44 gram of carbon dioxide. C, 28 gram of N2 and 32 gram of O2. Option D, 12 gram of carbon and 23 gram of sodium. Here you have to look into 1 atomic mass unit. So option A, 16 gram of O2 is equal to 1 atomic mass unit and 4 gram of H2 is not equal to 1 atomic mass unit. Hence this is not correct. Option B, 16 gram of O2 and 44 gram of carbon dioxide. This is also not equal to 1 atomic mass unit. Option C, 28 gram of N2 equal to 1 atomic mass unit and 32 gram of O2 is equal to 1 atomic mass unit. Option D, 12 gram of carbon equal to 1 atomic mass unit and 23 gram of sodium equal to 1 atomic mass unit. So here option C and D are consist of same number of atoms. Hence correct answer is option C and D. Question number 17. How many ml of water must be added to 200 ml of 0.65 molar HCl to dilute the solution to 0.20 molar? Options A, 450 ml, B, 400 ml, C, 350 ml, D, 500 ml. Let us see the solution. So we know that M1 V1 is equal to M2 U2. So this is molarity and volume for one set of solution, and this is molarity and volume for the second set of solution. So first set I will take this set, that is 0.20 molar solution. So volume is unknown, that we have to calculate. Let us take it as X. Then M2 is 0.65 and having volume of 200 milliliter. Substitute and simplify, you will get the value of X, that is 650 milliliter. So there is already exists 200 milliliter of HCl. So what amount of water must be added to make it as 0.20 molar? That can be taken by subtracting 650 ml minus 200 ml. That will give rise to volume of water must be added, that is 450 ml. Hence the correct option is option A, 450 ml. Question number 18. What is the volume of N by 4 NaOH required to neutralize 100 ml of N by 2 HCl? Options are A 500 ml, B 300 ml, C 200 ml and D 600 ml. Let us see the solution. So we can use the formula of N1V1 is equal to N2V2. So here two solutions are there, acid and base. So N1V1 let it be of acid and N2V2 let it be of base. So here N1 and N2 are the normality of acid and base and V1 and V2 are the volumes of acid and base respectively. So substitute the values. So N1 that is normality of acid HCl that is 1 by 2. Then volume is 100. N2 is 1 by 4 that is normality of base NaOH and V2 volume of NaOH we have to calculate. Simplify. So you will get for the V2 you will get an answer of 200 ml. Hence correct option is C 200 ml. Question number 19. Metallic chloride contains 42.22% metal. Calculate equivalent weight of the metal. Options A 39.68, option B 31.76, option C 36.35, option D 33.46. Let us see the solution. Suppose weight of the metallic chloride is equal to 100 gram, then weight of the metal will be 47.22 gram. Then weight of the chlorine we can calculate 100 minus 47.22 that is 57.78 gram. Therefore, equivalent weight of the metal can be calculated by using the formula of weight of the metal divided by weight of the chlorine into molar mass of the chlorine. So 47.22 divided by 52.78 into 35.5. So you will get an answer of 31.76. Hence correct option is option B 31.76. Number 20. Boron has two stable isotopes 10 boron, which is having relative abundance of 19% and 11 boron, relative abundance 81%. Average atomic weight for boron in the periodic table is option A 10.8, option B 10.2, option C 11.2, option D 10.0. Let us see the solution. So average atomic mass can be calculated by using the formula relative abundance of first isotopes into mass number of first isotope plus relative abundance of second isotope into mass number of second isotope divided by relative abundance of first isotope plus relative abundance of second isotope. So Ra here represents relative abundance, NO represent mass number. So substitute the values. So relative abundance of first isotope is 19 into mass number is 10 here, then plus relative abundance of second isotope is 81 into mass number is 11 divided by 100. 100 is nothing but 81 plus 19, relative abundance of 1 plus relative abundance of second isotope, 100. So substitute, simplify, you will get an answer of 10.81. So hence correct option is option A 10.81.